Alright, what's up, Mr. Song? So we're going to be working out a few problems on the board today. So problem number one, it says a basketball player makes 80% of her free throws. Supposedly, she takes 60 shots, right? So for part A, it's asking us to identify the parameters, which are going to be N, P, and then 1 minus P. So I already pre-wrote those down. So N is going to be 60, because that's 60 shots. P is the probability of success, which is 0.8 because it's 80% of her free throws. And then the probability of missing is 1 minus P. So we're just going to go 1 minus 0.8 and you get 0.20. Alright, so now it's going to ask us to compute the mean and also our standard deviation. So mean is just going to be N times P, which that is going to give us 60, and then you multiply that by 0.80, which this is going to give us 48. And then to calculate our standard deviation, it's going to be square root of N times P, and then it is going to be multiplied by 1 minus P. And basically, just to save you some time, the answer is going to be 3.10. So this is going to be our standard deviation right here, and then the mean on average is 48. And so for problem number C, it's asking if we can use normal approximation. So we need to check NP. So if NP, which is our mean, 48, then we put it into the formula, which is N 1 minus P. And so that is just going to give us 12. So since 12 is greater than or equal to 10, normal approximation can be used in this problem. Alright, D. When using normal approximation, we have to use that to estimate the probability that she makes 50 shots. So we're going to write down that our mean is equal to 48, and then also our standard deviation, take that into account, is 3.10. Alright, so we need to find our z-score, which is equal to 50, because that's the amount of shots she makes, minus 48, and we put that all over our standard deviation. And that is going to give us 0.65. So, since we have to go to the z table, we need to see what the probability is that she's going to make 50 shots. So, when we see 0.65 on the z table, that translates to 0.7422. And so, when we put that into a percentage, we have to take that into account 1 minus whatever the z-score is. And so that gives us 25.78%. So in total, she has a 25.78% of making at least 50 shots. And the last one is our reflection. So why are we going to use normal approximation? Basically, it is faster and easier than calculating the binomial probabilities by hand, especially with large numbers. Alright, so problem number 2, we have a population has a mean of 60, standard deviation of 12, and the sample, which is n equals 36, was taken. So for problem A, it's asking what is the mean and the standard deviation of x bar. Well, we have our mean right here, so mean mu is 60, and so now we have to find x bar or the standard deviation of x bar. So we're going to go standard deviation equals 12 over the square root of the sample size, which is 36, right? So this is going to equal 2, because 6 over, or what am I saying? 12 over 6 is going to give you 2. All right. Problem B is asking for the probability of the sample mean being over 63 plus including our z-score. So to find that, we're going to go z equals 63 minus 60 over 2. And so this is just going to give us 1.5. All right. And so now we have to look up the z table and find the probability. And so on the z table, 1.5 is going to get us to 0.9332. And so basically the chances of getting greater than 63 are equal to 6.68%. All right, and so then problem C, it's asking us to sketch the curve, right? So we're gonna draw a little bell curve right here. I'm not very good with these, so bear with me. Woo! Right. Yeah. And then so we're gonna draw our line right here. And this is gonna be our baseline, which is gonna be 60. All right, and so then we have to go another way and go to 63, which is gonna be right here. And basically, what we're gonna take is this whole entire section on the right. And so that's gonna lead us to 4, or not to 4, but it adds in to the central limit theorem. So basically, even though the population isn't normal, the sample mean is still going to be normally distributed if n is going to be large enough. All right, so for D, it's asking us if the sample size is going to be equal to 100, how would the standard deviation of x bar change? All right, and so if n, basically what's going to happen is we're just going to do this. 12 over the square root of 100. And so this is just going to be it's going to be 12 over 10, which is going to give us 1.2. So it's just going to go down like 0.8 in value. So this basically leads us to believe that a smaller standard deviation means sample sizes are going to be more tightly packed around the population mean. And then basically E, we have to explain the law of large numbers, and basically as n increases, the sample mean gets closer to the population mean. All right, so third problem is a random sample of 50 students has an average GPA of 3.15. Assume the population standard deviation is 0.4%. So for number 1, it's asking us to construct a 95% confidence interval. As you can see, I've already done it right here with this formula, right? And so that is just going to give us 1.96, all right? And then it's asking us to find also the margin of error. So we're going to plug it into this equation, 1.96 times 0.4 over the square root of 50, which is going to give us 0.11. And then we find our interval. And our interval is going to be parentheses 3.04, 3.26, all right? And so now it's, for problem number 2, it's asking us to interpret, and basically we're 95% confident that the true GPA is between the lower and the upper bound right here. And then, so for problem number 3, it's asking us to sketch with the upper and lower bounds. And so as you can see here, I did the little bell curve, right? So our lower bound is 3.04. Our kind of average, our central area right here is 3.15. And then our upper bound is going to be 3.26. And now it's asking us to make a 99% confidence interval. And so we're just going to use the same equations that we had up here, or the same formulas we had up here, to find our z, which is going to give us 2.576, which gives us a much wider margin of error. And it's actually going to make us a new interval, which is between 3.04 and 3.28. And then, so why this change occurs is because our new margin is going to be 1.96 times 0.4 over the square root of 100, and that's going to give us 0.078. And now we have to construct a whole new interval, which is going to be between 3.04 and 3.228. And essentially, for the summary, higher confidence is equal to a wider interval, and a bigger sample is equal to a much more narrow interval. All right, so problem number 4 says the soda company says their cans have 12 fluid ounces, and a sample mean of 40 cans are 11.92 ounces with a standard deviation of 24. All right, so for number 1, we're going to have to find the null and the alternative hypotheses. So the null hypothesis is going to be, the mean is going to be 12, and we need to find out if they're one-sided. This one isn't. And then the other hypotheses, the mean is less than 12, which means this is one-sided, right? So that's problem number 1. Problem number 2 is asking us to compute the test statistic. So we have z right here. Z equals 11.92 minus 12 over 0.24, which gives us negative 2.11, which in turn, we now have a p-value of 0.0174. For number 3, it's asking us if at the 0.05 level, and it's asking us for a conclusion. And so our answer for this is, since p is less than 0.05, we reject the null hypothesis instead of the alternative hypothesis. And this basically says that there is evidence that cans are less than 12 fluid ounces, right? And so then, for our sketch, we have a bell curve right here, 12 being center, and then 11.91 being on the left side, and we're going to highlight this left tail. And that basically just shows us the value of everything right here. And then number 5 is asking us for a concept. And the concept really for the p-value is that there is a chance of getting a result this extreme if our null hypothesis is true. But a smaller p-value is equal to a strong chance that there is going to be more evidence that's against our null hypothesis. All right, last problem, number 5. Basically, a nutritionist tests a diet's change in cholesterol from 200 milligrams. Our sample is going to be 15, mean is 194, and our standard deviation is 20. All right, so for question 1, it's basically just asking us to state the null and the alternative hypotheses. So our null hypothesis is mu equals 200, and then our alternative hypothesis does not, it can be equal to 200, which indicates that this is a two-sided test, right? And then so it moves down to number 2, which is asking for our test statistic / the degree of freedom. So when we do the calculation, so I already put it in the formula, t is equal to 194 minus 200 over 20 divided by the square root of 15, right? And so that's going to give us negative 1.94 as our answer for our test statistic. And then our degree of freedom is going to be 14. And then so for number 3, it's asking for the critical value from the degree of freedom at a 0.05, which leads to t being plus or minus 2.145. And that actually leads into our sketch, because when we sketch it here, 0 being our midpoint, the lower bound at negative 2.145 and the upper bounds at 2.145, anything past that is included in the rejection zone. But when we have our test statistic right here at negative 0.194, it's accepted because it's within that range of not being outside into that rejection zone. And then number 5 is going to ask us for our confidence interval. So t is going to be just regular at 2.145. And so when we get to the margin, we have 2.145 times 20 over the square root of 15, which is going to give us 11.07. And it leads us to going to our interval, where we get 182.93 and then 205.07. But this is including 200 right here in the middle. And then for our last question, it's basically asking us to compare t and z. And so both are used to compare sample to population, but t is used when population standard deviation is unknown and the sample size is actually pretty small.